Hi everyone, my name is Chen Li from National Cheng Kung University. Today I would like to share our technology, high profitable financial recommender system with graph machine learning. The goal of this tech is that given the future metrics that depicts the stock's price in the past few days, for example, we have several this company illustrated in these figures. Our goal is to recommend a list of top K stocks. This company that can produce highest return ratio in the next stocking day. There are two difficulties or challenges we are trying to solve this problem. The first one is that the stock price is a kind of time series data. For example, we have the Tesla this company here. In this company, we can see the historical time series. If we would like to predict its return ratio or its stock time series values, we need to model the long-term and short-term tendency of the price value for this company. This criterion shows the up and down tendency will be very difficult to model. The second challenge is that we need to model the hierarchical stock sector relationship. What is the stock sector relationship? This figure gives an intuitive example. For example, we may have the intra-sector relation, which means that there could be investigating a member of or owned by relationship between companies. And as for the sector relationship, we may have the potential inference between different kinds of sector. For example, the goal of texture can be influenced by oil sector. However, to model the stock sector relationship, we need to collect the private information that can depict the relationship between company or between sector. However, such kind of relationship is time evolving, and they are also hard to be handcrafted. So, given it is impossible to collect such kind of data, it is very difficult to model the sector stock relationship. In our technology, we present a machine learning-based model, financial attention network. In this network, consists of three components. The first component is stock level modeling. In the stock level modeling, we use the sequential deep learning model GRU to model the historical time series for given past few weeks. Then we use a graph attention network to model how stocks or how this company are influenced with each other. Then we aggregate the obtained feature representation from graph neural network to generate the short-term stock representation. And again, we apply sequential model GRU to model their long-term sequential feature representation. And the second step is sector level modeling. In sector level modeling, we consider that different sectors can be influenced with each other, consider regarding their stock price. So we aggregate the obtained representation from stock level to sector level, then construct a sector graph. Again, we apply graph attention network to generate the stock embedding, the sector level embedding. The second stage of this model is that we try to fuse the embedding obtained from stock level modeling and also on sector level modeling to be the final embedding. At last, we conduct a dual task learning module. The first task is to predict the rank the profitable stack. The second task is to predict the stock movement, which means that the stock will go up or down. We combine these two tasks together for the overall model training. Here is the experimental result. we conduct the experience based on Taiwan stock or American stock S&P 500. And our fine-gate model is compared with several steps of the stock price prediction model for recommendation task. We can find that our fine-gate model can consistently outperform the state-of-the-art model for stock recommendation on both Taiwan stock or S&P 500. In addition, our model allows users to specify their interest stocks. We consider 5 different scenarios for a user to specify their interest stocks. And based on their interest of stocks, we further recommend the most profitable ones among the candidates. And it can show that based on the result, our fine-gate model can further outperform all of the state-of-the-art models. Even we can obtain nearly 100% accuracy. The potential application of our technology is to increase the market value of these companies, or we can also, based on the high predictability of the profitable stocks, we can boost the transaction value of the banking industry and further rise the customer weakness. The fine-gate related technology has been extended to Taiwan's financial institutions such as Bank Sinopec or Yishun Bank. Last, we would like to highlight that the code or implementation of our fine-gate model has been released at GitHub. And this tech is also published as a research paper and will be appear in IEEE TKDE. You can access the code and paper using these QR codes. This is our technology. Thank you.